Hello everyone. Today I am going to tell some results on number of elements in sets, solutions of examples and exercise 1.6. We all know that the finite sets are the sets which contain all countable or finite number of elements. For example, if you see this example, A is equal to 1, 2, 3, 4. So here there are 4 elements in set A, and in B there are 3 elements, and C there are no elements because this is an empty set. So the number of elements of the set is denoted by n of A, n of B, etc. And here you can write n of A is equal to, there are 4 elements, so 4, n of B is 3, and n of C is equal to 0. And we also know that infinite sets are the sets which has infinite number of elements. For example, natural numbers, integers, all these sets are infinite sets. And here are the results of number of elements. The first one is, if AB are finite sets and A intersection B is equal to an empty set, that means A and B are disjoint sets because here there are no common elements in sets A and B. So in this case, for example, if you see here A is equal to 1, 2, B is equal to 3, 5, 6, then A union B is equal to 1, 2, 3, 5, 6. And A intersection B is an empty set because here there are no common elements in these two sets. Then this is an empty set. Then n of A. So the elements in A set are 1, 2. There are 2 elements. And n of B, there are 3 elements in B, so 3. And n of A intersection B. So that is an empty set, so 0 elements. So 0. And n of A union B, you can see here, in A union B, there are 5 elements, 1, 2, 3, 4, 5. So 5 elements. Similarly, if you see this example, here there is only 1 element, so 1. And here in B, 2 elements. And A intersection B, 0. And A union B, there are 3 elements. So here n of A union B is 5 and n of A union B is 3 here. So if you observe here, 2 plus 3 is 5. And here 1 plus 2 is 3. So n of A union B is equal to n of A plus n of B. In case A intersection B is equal to an empty set. And you see here, similarly, if you take A minus B, so A minus B means you have to write only A elements excluding B elements, that means common elements. So here 1, 2, there is no common element, so 1, 2, only 1, 2. And B minus A, only write B elements excluding A elements, so 3, 5, 6. So n of A minus B is 1, 2, 2 elements, so 2. N of B minus A is 3. And n of A intersection B is 0. Here also in this case, the same case. So 0. And n of A union B. A union B are 1, 2, 3, 5, 6. So 5. And in the second example, n of A minus B is A, B minus A. There are 2 elements, so 2, 0, and 3. So here 2 plus 3 is 5 and 1 plus 2 is 3. So we can also write n of A union B is equal to n of A minus B plus n of B minus A. So if A intersection B is equal to an empty set, then you can write n of A union B is equal to n of A plus n of B, or n of A minus B plus n of B minus A. This is a representation of n of A union B by Venn diagram. If A intersection B is an empty set, that means there are no common elements in AB sets. Then there are no common elements, so A set is this one and B set is this one. So n of A, the number of elements in A and number of elements in B. Then n of A union B is equal to n of A plus n of B. And here also A minus B, because A intersection B is an empty set, A minus B, and this is B minus A. So n of A union B is equal to n of A minus B plus n of B minus A. And in the second case, if A intersection B is not equal to an empty set, that means A and B are not disjoint sets. So there are some common elements are there, and AB are finite sets. And see these examples. In A 1, 2 and B 1, 3, 5, and A union B 1, 2, 3, 5. A intersection B, there is only one common element 1, and n of A is 2, n of B is 3, n of A intersection B only one element 1. And similarly, in this example, n of A only 1, n of B 2, n of A intersection B only one element. And n of A union B. So 4 elements, so 4, n of A union B here 2. And if you observe 2 plus 3 minus 1, 5 minus 1 that is 4, and 1 plus 2 minus 1 that is 2, 3 minus 1 that is 2. So if A intersection B is not equal to an empty set, then n of A union B is equal to n of A plus n of B, n of A plus n of B minus n of A intersection B. Similarly, in this case, A intersection B is not equal to an empty set, and A minus B, or only you have to write A elements excluding the common element, that is 1. So 2, and here B minus A, 3, 5, and n of A minus B, only 1, and n of B minus A, 2 elements, and n of A intersection B, only one common element, so 1, and here n of A minus B, here no elements, because A minus B, there are no elements, A is the common elements, you have to exclude that, and B minus A only O, and n of A minus B 0, and n of B minus A 1, n of A intersection B, here only one element, A is the common element 1, and n of A union B 1, 2, 3, 5, 4 elements, and here 2. So if you observe here 1 plus 2 plus 1 is 4, and 0 plus 1 plus 1 is 2. So n of A union B is equal to n of A minus B plus n of B minus A plus n of A intersection B. In this case, n of A plus n of B minus n of A intersection B, here plus n of A intersection B. If you see the Venn diagram, then you will understand. Here, n of A union B, in this case, A intersection B is not equal to an empty set. Then this is A set, this is B set, and there are some common elements. So A intersection B, this is A intersection B, and n of A union B is n of A. That means full elements, and here full elements of B minus you have to exclude these elements, A intersection B. So minus this one. And in this case, A minus B means you have to exclude the common elements. Common elements in this case, so n of A minus B. And here also you have to exclude the common elements. B minus A means excluding the common elements. So n of B minus A plus you are excluding this part in this case and in this case. So you have to add this part. So n of A intersection B. This is n of A union B. If you see this Venn diagram, here n of A you can write as n of A minus B plus n of A intersection B, or if you want to find n of A minus B, that is equal to n of A minus n of A intersection B. And here n of B is equal to n of B minus A plus n of A intersection B, or n of B minus A is equal to n of B minus n of A intersection B. These are examples from Ncert. Example 23rd. If X and Y are two sets such that X union Y has 50 elements, X has 28 elements, and Y has 32 elements, how many elements does X intersection Y have? So here the number of elements in X union Y are 50 elements. So n of X union Y is equal to 50, and n of X is 28, and n of Y is equal to 32. And here you have to find how many elements in X intersection Y. So n of X intersection Y you have to find. We know that n of X union Y is equal to n of X plus n of Y minus n of X intersection Y. Because we learned here n of A union B is equal to n of A plus n of B minus n of A intersection B if A intersection B is not an empty set. So substitute these values here. 50 is equal to 28 plus 32 minus n of X intersection Y. So you will get n of X intersection Y is equal to 10. So there are 10 elements in X intersection Y. And this is 24th example. In a school, there are 20 teachers who teach mathematics or physics. Of these, 12 teach mathematics and 4 teach both physics and mathematics. How many teach physics? So here let M denote the set of teachers who teach mathematics and P denote the set of teachers who teach physics. So here 20 teachers teach mathematics or physics. We know that if X belongs to A or X belongs to B, then that is A union B. So here this is N of M union P. the number of elements in M union P. M means the set of teachers who teach mathematics. And here 12 teach mathematics. That means N of M is equal to 12. So you can see here N of M is 12. N of M union P is 20. And 4 teach both physics and mathematics. You can see here X belongs to A and X belongs to B. That means A intersection B. So here N of P intersection M is equal to 4. So right here, how many teach physics? So N of P you have to find. Now, we know that N of M union P is equal to N of M plus N of P minus N of M intersection P. Here you have to find N of P value. Remaining values already given here. So substitute these values here. You will get N of P is equal to 12. Hence, 12 teachers teach physics. This is 25th example. In a class of 35 students, 24 like to play cricket and 16 like to play football. Also, each student likes to play at least one of the two games. How many students like to play both cricket and football? So here there are total 35 students. So N of X union Y. For example, if you assume the set of students who like to play cricket, that is X, and who like to play football, that is Y, then N of X is 24 and N of Y is 16 and N of X union Y is 35. And here we have to find both the students like to play, how many students like to play both cricket and football. So N of X intersection Y you have to find. First write the given values here and substitute all the values in this. N of X union Y is equal to N of X plus N of Y minus N of X intersection Y. So you have to find here N of X intersection Y. If you substitute the given values here, then you will get N of X intersection Y is equal to 40 minus 35, that is 5. So if you cross-check here, 24 plus 16, that is 40. 40 minus these 5 students. So you will get 35 students. You can cross-check like that. Hence, 5 students like to play both cricket and football. This is 26th example. In a survey of 400 students in a school, 100 were listed as taking apple juice, 150 as taking orange juice, and 75 were listed as taking both apple as well as orange juice. Find how many students were taking neither apple juice nor orange juice. So let the students who are taking apple juice be X and the set of 4 students. The set of students who are taking orange juice be Y. Then N of X is 100 and N of Y is 150. And both apple and as well as orange juice, the students are N of X intersection Y. That is 75. So write the given values here. And here find how many students were taking neither apple juice nor orange juice. So here's some other students who are taking neither apple juice nor orange juice. So we have to find this. So you have to assume this as N of U, because here N of X plus N of Y minus N of X intersection Y. This is N of X union Y. So you have some other students also who are taking neither apple juice nor orange juice. So you have to assume this as a universal set. So let's assume U as the set of students. So N of U is equal to 400. So write here. And now first find the value of N of X union Y. Substitute all the given values here. You will get 175. So if you see this Venn diagram, you will understand. The students who are taking apple juice are this one, and here the orange juice, and both are this one. And the students who are taking neither apple juice nor orange juice, the students are here only. So you have to find this value. So you have to subtract this full from universal set. So N of U minus N of X union Y. This is X union Y. So N of U minus N of X union Y, that is 400. N of U is 400 minus 175. That is equal to 225. Hence, there were 225 students taking neither apple juice nor orange juice. 25 students were taking neither apple juice nor orange juice. This is 27th example. There are 200 individuals with a skin disorder. 120 had been exposed to the chemical C1, 50 to chemical C2, and 30 to both the chemical C1 and C2. Find the number of individuals exposed to. The first one is chemical C1 but not chemical C2, chemical C2 but not chemical C1, third one chemical C1 or chemical C2. So here there are 200 individuals and 120 had been exposed to the chemical C1 and 50 to chemical C2. So if you assume this as A, the set of the people who had been exposed to the chemical C1, that assumed as A, and this had been B, then N of A is equal to 120 and N of B is equal to 50. And this is 30 to both the chemical C1 and C2. So N of A intersection B is equal to 30. If you add 120 plus 50, 170 minus 30, that is 140. So it is not N of A union B. So 200 is not N of A union B. So you have to assume this as universal set. So N of U is equal to 200 here, and N of A is 120, N of B is 50, and N of A intersection B is 30. And here chemical C1 but not chemical C2. That means you have to exclude B. C1 is, that is A. So you have to exclude B. That means N of A minus B. And here C2 but not C1. That means you have to exclude A. You have to take B. So N of B minus A. And here C1 or C2. So if you see here, or X belongs to A or X belongs to B, that means you have to find N of A union B. So you have to find these three values. So assume, first write all the sentences here. You have to assume like this and given values here. Now, if you see this Venn diagram, you will understand. This is universal set. So total N of universal set, the N of U is equal to 200 and N of A, so 120, N of B 50, both 30. So you have to find N of A minus B. So directly you can find 120 minus 30 is 90. Here also 50 minus 30 is 20. So directly you can find like this by using this figure. And if you want to calculate by using the formula, you have to find N of A is equal to, here this is N of A. So N of A is equal to N of A minus B plus N of A intersection B. So right here and substitute the values here. Then you can find N of A minus B is equal to 120 minus 30. If you subtract 30 minus 120, this is full is 120. So if you subtract this, then you will get 90. 90 means only this part, A minus B. Okay. Then second one, you have to find N of B minus A. So 50 minus 30, that is 20. So by using the formula, you can find like this. N of B is N of B minus A plus N of A intersection B. So N of B minus A is 20. 50 minus 30, that is 20. Now, third part is N of A union B. That you can find by using N of A plus N of B minus N of A intersection B. So substitute the values here, then you will get 140. And or you can find by using N of A minus B, N of B minus A plus N of A intersection B. If you add all these three values, you can directly find N of A union B. Because you already got these values, N of A minus B, N of B minus A, those are 90 and 20. If you add this 30, then you will get 140. These are the solutions of exercise 1.6 from Ncert. First one is, if X and Y are two sets such that N of X is equal to 17, N of Y is equal to 23, and N of X union Y is equal to 38, and find N of X intersection Y. So here directly the values are given here. So you have to find N of X intersection Y by using the formula like this. N of X union Y is equal to N of X plus here N of Y. This is N of Y minus N of X intersection Y. Then if you substitute all the values, given values, then you will find N of X intersection Y is equal to 40 minus 38, that is equal to 2. So this value is 2. And second question, if X and Y are two sets such that X union Y has 18 elements and X has 8 elements and Y has 15 elements, how many elements does X intersection Y? So here also directly X union Y has 18 elements. That means N of X union Y is given. Here X, so N of X, that is 8 elements, that is also given. N of Y is given. How many elements does X intersection Y? That means N of X intersection Y you have to find. So first write the given values here, and if you substitute all the values here, then you will get n of x intersection y is equal to 5. So this set contains 5 elements. X intersection y contains 5 elements. And this is the question. In a group of 400 people, 250 can speak Hindi and 200 can speak English. How many people can speak both Hindi and English? So here, let X be the set of students who speak Hindi. So who speak Hindi, the set you have to assume as X. And who speak English, the set you have to assume as Y. So here n of X who speak Hindi, that is n of X is equal to 250, n of Y is 200, and in a group of 400 people, so n of X union Y, that is 400, both Hindi and English, both you have to find. So that means n of X intersection Y you have to find. So write the given values here and substitute all the values here. In this 400 is equal to 250 plus 200 minus n of X intersection Y. Then n of X intersection Y is equal to 450 minus 400, that is 50. Hence 50 students can speak both Hindi and English. If you add all the values, 250 plus 200, that is 450 minus 50, you will get this value 400. You can check like that. And next one is fourth problem. If S and T are two sets such that S has 21 elements, T has 32 elements, and S intersection T has 11 elements, how many elements does S union T have? So here directly given S has 21 elements. So n of S is equal to 21, n of T is 32, and n of S intersection T is 11. You have to find how many elements does S union T. So n of S union T you have to find. So write the given values here, and in this you have to substitute all the values. 21, 32 minus 11, you will get 42. So S union T has 42 elements. This is fifth question. If X and Y are two sets such that X has 40 elements, X union Y has 60 elements, and X intersection Y has 10 elements, how many elements does Y have? So here you have to find n of Y. N of X is given, n of X union Y is given, n of X intersection Y. So write the given values and substitute all the values here. You have to find n of Y. So here if you substitute all the values, then you will get n of Y is 40 minus the 10, that is 30. So 60 minus 30 is 30. So therefore Y has 30 elements. And sixth question. Here in a group of 70 people, 37 like coffee, 52 like tea, and each person likes at least one of the two drinks. How many people like both coffee and tea? So here total 70 people. So each person at least one of the two drinks they like. So here it is n of C union T. For example, if you assume C be the set of people who like coffee and T be the set of people who like tea, then this is n of C union T, because here at least one of each person likes at least one of the two drinks. So this is n of C union T. And here coffee, the people who like coffee, the number of people n of C is equal to 37. And T, the number of people n of T is equal to 52. And here you have to find how many people like both coffee and tea, both and coffee and tea. So you have to find n of C intersection T. So write all the given values here and substitute the values in this. And 70 is equal to 37. This is 37 plus 52 minus n of C intersection T. We have to find this value. Then 89 minus 70. That is n of C intersection T. That is 19. Hence 19 people like both coffee and tea. If you add all these values, see here, 37 plus 52, 89. 89 minus 19, that is 70. You will get this value. You can check like that. So next one is Next one is 7th question. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? How many like tennis? So here, let C be the set of people who like cricket and T be the set of people who like tennis. So 40, this is N of C. And here, in a group of 65 people, so N of C union T. This is N of C union T. And 10 like both cricket and tennis. So N of C intersection T, this value. And here, how many like tennis only and not cricket? So you have to exclude cricket. That means you have to exclude C. Cricket means C. So you have to find N of T minus C. Only tennis, but not cricket. So you have to exclude only cricket. That means you have to exclude C. You have to include T. Here, how many like tennis? So how many like tennis means N of T. These people can also like cricket also. So N of T. This is the difference between this and this. This is N of T means they like tennis. They can play. They can like cricket also. But here they only like tennis but not cricket. So you have to exclude completely C here. This is the difference between these two values. And if you write the given values here you have to find these two values, N of T minus C and N of T. So first you find N of T. N of C union T is equal to N of C plus N of T minus N of C intersection T. Here you know all the values except this value N of T. So substitute all the values, then you will get N of T. N of T is equal to 35. N of T. Here N of T is the people who like tennis. That is N of T. And next one is N of T minus C. N of T minus C means you have to exclude from N of T to you have to exclude these people, C people, cricket people from the tennis people. So N of T minus N of C intersection T. That means the common people you have to exclude. So that is 35 minus 10, that is equal to 25. So here, if you see this Venn diagram, you will understand. Here, this is N of T, full, this is N of T, that is 35. From this, you have to exclude this part, then you will get T minus C. So you have to exclude this part, that is T minus C. This is 25. So these people are 25. And N of T is this value, 35. And only these people, 25. If you add 25 plus 10, these people are 10. 25 plus 10, then you will get N of T again, 35. Hence, 35 people like tennis and 25 people like only tennis, not cricket. So here the difference is these people also can like cricket, 35 people. But here only these 25 people only like tennis. They don't like cricket. This is the difference between these two. This is a problem. In a committee, 50 people speak French, 20 speak Spanish, and 10 speak both Spanish and French. How many speak at least one of these two languages? So here let F be the set of people who speak French. Those are 50. So N of F is equal to 50. And S be the set of people who speak Spanish. So N of S is equal to 20. And both languages the number of people who speak both languages are 10. So that is 10. N of F intersection S is equal to 10. And here you have to find how many speak at least one of these two languages. That means you have to find N of S union F. Now substitute all the given values here. N of F union S is equal to N of F plus N of S minus N of F intersection S. Substitute all the given values here, then you will get 60. And 60 people speak at least one of these two languages. Now practice these questions. And these are the answers.